Next important topic is transformation of the independent variable. N is the independent variable for the case of the discrete time signal. T is the independent variable for the case of the continuous time signal. So you have covered in class that we transform the independent variables and in the transformation of the independent variable, the shape of the signal does remain the same. The shape of the signal will remain same, however it will be shifted either to right, either to left, or it will be compressed, or it will be expanded, or it will be time reversed, but the shape of the signal will remain the same. So the first of all, the first transformation that is named is time shift, and time shift has two types. One is time delay, time advance. For example, let us study the time delay. So x of t minus t naught, for example, if the given signal is x of t, and then the x of t minus t naught, this will be the time delay signal, and x of n minus n naught, this is the case of the discrete time signal. If t naught is greater than 0 and n naught is also greater than, the signal is shifted to the right. In time delay, the signal will be shifted to the right. For example, this is x of t and this is x of t minus 1. So it is shifted to the right with 1 unit. With 1, it is starting from 0 and going to 2. However, this signal is starting from 1 and going to 3. The shape of both the signal is same, however this signal is shifted to the right. So we say that this signal is delayed, 1 unit delayed with respect to the x of t, with x of t. So this is the case of the time shift. And which type of the time shift? Time delay. If the signal is moved to the right of the original signal with respect to the given signal, the given signal is taken as a reference, and the resultant signal is shifted to the right. So we say that this is the time delayed signal. And time advanced, for example, x of t minus t naught and x of n minus n naught, t naught is less than 0 and n naught is also less than 0, signal is shifted to the left. T naught and naught will be some numbers, for example 1 2 3 4 5, it will be some number. So the if the value is t naught is, for example, minus 2, so it will become like this, x of t plus 2. So like this, here the value of t naught is minus 1, so it became x of t plus 1, it become x of t plus 1. Here the value of the t naught is minus 2, so the signal will become x of t plus 2. So if you see, this is the given signal which does start from 0 and end at 2, and this is the sketch of the x of t plus 1. If you see, it is shifted to the left with respect to the x of t. The x of t does start from 0 and ends at 2. However, x of t plus 1 does start from minus 1 and ends at 1. So you see that it is shifted to the left. This is the time advance. This is time advance. Next is time reversal. X of t is obtained from signal, x of minus t, x of minus t, x of minus t, x of minus t is obtained from x of minus t is called as the time reversal, is called as time reversal, and is obtained from signal x of t by a reflection about t is equal to 0, where x of minus t is time reversed version of x of t. So see over here, this is the x of t and this is the x of minus t. If you see, the value of the x of t at minus 1 goes to the appears at t is equal to 1, and the values of the signal at t is equal to 1 does appear at t is equal to minus 1. The value of the signal in x of t at t is equal to 2 does appear at t is equal to minus 2 in x of minus 2. So it is reflected about t is equal to 0. In case of the discrete time signal, if you see, the x of n is given, its value is 0 at t is equal to n is equal to 0, its value is 1 at n is equal to 1, its value is equal to 3 at n is equal to 2, its value is equal to minus 2 at n is equal to 3. Now its time reversed version is this one, x of minus n. If you see, the value at at n is equal to 1 will be appearing at n is equal to minus 1. The amplitude is not changing, however the position of the sample does change. The sample in x of n at n is equal to 1 will be shifted to n minus 1. The sample at n is equal to 2 will be shifted to n is equal to minus 2. The sample at n is equal to 3 will be shifted to n is equal to minus 3. However, their amplitude will remain the same. This is the example of the time reversal. Now, the another important type of the independent transformation of independent variable, that is time scaling. So if we scale the signal, if we scale the independent variable, independent variable, the resultant signal will either be compressed as compared to the original signal, or the resultant signal will be expanded in time with respect to the original signal, and it does depend on the factor of scaling. For example, if you see over here, this x of alpha t, we call it as a time scaled version of x of t. X alpha t is a time scaled version of x of t. Value of alpha will decide whether it is time compressed or expanded signal, whether it is time compressed or time expanded signal. So let us see first the compression in time. This is the x of t given, and it is defined from minus 2 to 2. This is the original signal. Now I need to plot x2 of t. Here the value of alpha is equal to 2. So alpha value is 2, and now the resultant signal is defined over the range from minus 1 to 1. However, the original signal is defined from minus 2 to 2, and here the resultant signal or the time scaled signal is defined over from minus 1 to 1. So what does it mean? That the signal is compressed. Signal is compressed. And if the alpha value is, here the alpha value is 1 over 2, sorry, here in this case the alpha value is 1 over 2 means the alpha value is less than 1.5. So here if you see, the resultant signal is expanded. It is defined over the range from -4 to 4. So the resultant signal is expanded as compared to the original x of t. So these are the few important tips which need to be remembered for the case of the time scaling. X alpha of t is a time scaled signal if this x of alpha t is a time scaled signal if magnitude of alpha is greater than 1, then the signal is linearly compressed. If the alpha value is greater than magnitude, its magnitude is greater than 1, like the case over here, 2 is greater than 1, so the signal is compressed. And if the magnitude of the alpha is less than 1, then the signal is linearly expanded, like the case over here. Here the alpha value is less than 1, that is 0.5. So the resultant signal is expanded. So these are the two important points which needs to be remembered. And one important thing, that the time scaling, for example, the practical example of time scaling, if you play the audio and video at a high speed, so this is the case of time compression. And if you play the audio and video, either audio or video, at a slow rate, this is the case of the time expansion. You have expanded the time. It will take more time to complete that audio or that video. And the case of the time reversal, if you see, in the also the time the replay in the cricket match, that is also the case of the time scaling, that the ball is moving at a slow speed. What they have done, they have expanded the time. And sometime you see the ball is going back to show the actual position or actual scenario. That is the case of the time reversal. So another important thing is that the see this point, that the all transformation may be encountered at same time. We have studied the three type of transformation separately: time shift, time reversal, and time scaling. But you can have encounter all the three transformation at the same time as well. That is x alpha t plus beta, where alpha and beta are given number. Shape of the signal will remain same, except that resultant signal may be stretched if magnitude of alpha is less than 1. Here in this case, if alpha is less than 1, this resultant signal will be stretched or will be expanded. Compressed if magnitude of the alpha is greater than 1. This signal will be compressed if alpha is greater than 1. And this signal will be reversed in time if alpha is less than 0. If the alpha is less than 0, for example, if it is minus, so this will be reversed. And it will be shifted in time if beta is non-zero. If this beta has some non-zero value, for example 1 2 3 minus 1 1 is 2 3, so it will be shifted in time as well. So you need to be careful, so that you can encounter multiple transformation at the same time as well. This is how to draw the x alpha t plus beta from x of t. For example, n signal is given x of t, and you are asked to sketch and plot some transform signal. For example, in this case we are given these example. First is this x of t is given. First one is saying that find and plot x of t plus 1. Second one saying that plot x of minus t plus 1. Third one is saying plot x 3 by 2t, and the fourth one is saying that plot x 3 by 2t plus 1. So we have discussed this in class in detail, that how to plot the signal. Here we are just revising that how to plot the these type of, how to find and plot these type of signals. So the solution of the first example example is x of t plus 1. Solution for this is x of t plus 1. So this need to be find, so we name the independent variable so this need to be find, so we name the independent variable as tf. Here and is was written was mistakenly written, so this may be replaced by is. So we replace this t by tf. However, the independent variable of the given signal is named as tg, that is given, so we name that as tg. Create a table as below. First relate this t plus 1 equal to t, and first relate this t plus 1 here, this t plus 1, and this t is named as tf, as we need to find this t, and this t of the given signal, that is named as tg. So they are related as here tf plus 1 plus is equal to tg. They are related over here. tf plus 1 is equal to tg, and tf is equal to tg minus 1. So we need to create this table. So tf is equal to tg minus 1. tf is equal to tg minus 1. So when the given value of the independent variable is 0 here, so 0 minus 1 is minus 1. When the given value, the tg value is 1, so 1 minus 1, 0. tg is 2, so tf will be equal to 2 minus 1 is equal to 1. What does it mean? It means that this what does this mean? Sorry, what does this mean? 0 when the tg is equal to 0 and tf is equal to minus 1 means that the value of xt at t is equal to 0 will now appear at t is equal to minus 1. In the given signal, what was the value at t is equal to 0? Here the value of x of t at t is equal to 0 is equal to 1. So this will be shifted to minus 1, like here. See over here. Here the amplitude of the signal which was appearing at t is equal to 0 will be shifted to t is equal to minus 1 now. What does this mean? tg is equal to 1 and tf is equal to 0. It means that the value of x of t at t is equal to 1 will now appear at t is equal to 0. At t is equal to 1, x of t was equal to 1. Here in xt plus 1, the at t is equal to 0, it will be equal to 1. Same, what does it mean? T is equal to 2 and t is equal to 1. It means that the value of x of t at t is equal to 2 will be shifted to t is equal to 1. It means that the value of x of t at t is equal to 2 was 0. Now in this transformed signal x of t plus 1, this value at t is equal to 2 will be shifted to t is equal to 1. So do it practice and let me know if you have some confusion. You can also search it from Google, and also we have solved example on this transformation, but this is just a revision. The solution for the example 2, x of minus t plus 1, x of minus t plus 1, this example. In this case, again, you need to relate the independent variable of the finding signal and the given signal. So minus the finding signal independent variable is represented as tf, and the given signal independent variable is represented as tg. So these are related as minus tf plus 1 is equal to tg, implies that minus tf is equal to tg minus 1, and implies that tf is equal to minus tg plus 1. Think over here. Again, you need to define this table, this one. So where at one side you have to note the values of the the given independent variable, and on the other side you need to note the values of the independent variable of the signal of the independent variable of the finding signal. So if tg is equal to 0, tf is equal to minus 0 plus 1, 1. When tg is equal to 1, tf is equal to minus 1 plus 1, 0. When tg is equal to 2, tf is equal to minus 2 plus 1, minus 1. What does it mean? It means that the value of the x of t at t is equal to 0 will be shifted to t is equal to 1. The value of the x of t at t is equal to 1 will be shifted to t is equal to 0. The value of the x of t at t is equal to 2 will be shifted to t is equal to minus 1, and here is the final plot for this signal. Now let us define the third example, x of this one, x of 3 by 2t solution. Relate this independent variable 3 by 2 tf is equal to tg, and tf is equal to 2 by 3 tg. Now create this table, tg and tf is equal to 2 by 3 tg. Tg is equal to 0, tf is equal to 0, tg is equal to 1, tf is equal to 2 by 3, tg is equal to 2, tf is equal to 4 by 3. What does it mean? That the value of the x of t at t is equal to 0 will be shifted to 0. The value of x of t at t is equal to 1 will be shifted to 2 by 3. The value of the x of t at t is equal to 2 will be shifted to 4 by 3, and this is the final plot. Do practice over here, and you will understand what does I mean. If you have still any confusion, you can contact me, and also can search to find how to find this signal.